A very warm welcome. This is Joel Moses and Harish V presenting you the topic Mathematical Analysis for Non-Recursive Algorithms, the number of binary digits in n's binary representation. Coming to the topic, what is non-recursive algorithm? Algorithm that not uses recursion method to solve its problem is called non-recursive algorithm. A non-recursive algorithm does all the process at once without calling itself. And we have few examples of non-recursive algorithm that are insertion sort, matrix multiplication, element uniqueness problem, and bubble sort. Now, coming on to general plan for analyzing the time efficiency of non-recursive algorithms, first you have to decide on the parameters indicating the input size. That is the first step. Going on to the second, you should identify the algorithm's basic operation. Third step, you need to check the number of times the basic operation is executed depends only on the size of the input, or it also depends on some additional property. And based on that, you should investigate the worst case, average case, and best case efficiency. The fourth step, you have to set up a sum expressing the number of times the algorithm's basic operation is executed. The fifth step, you have to establish its order of growth based on some standard formulas and rules. Now, the question is, write an algorithm to find the number of binary digits in the binary representation of the positive decimal integer. It means you should count the number of binary digits in the given particular positive decimal integer n. Coming to the algorithm, the input is the given decimal integer n, and the output is the number of binary digits in the given positive decimal integer. To start off with the algorithm, first you should assign the value 1 to the variable count. Next is the while condition. The condition will be n, which is the positive decimal integer. It must be greater than 1. That is the condition. If it's greater than 1, then it goes into the while loop. Inside the while loop, we have count is equal to count plus 1. That is, count gets incremented by one value, and following that step you have n is equal to n by 2. So the positive decimal integer is divided by 2 inside the while loop. This sums up inside the while loop, and when the condition n is greater than 1 fails, it returns the count value. Now, to know the order of growth, we must follow 5 steps. So, coming to the first step, you should know the input size. We know here the input size is the positive decimal integer n. So, while knowing the input size, we can go to step 2. Step 2 is to identify the basic operation in the algorithm. So, if we see here, we are given many operations out here, but the most frequently executed operation here is the comparison operator, which is n is greater than 1, which is a while condition, which is more executed more number of times compared to the other operators performed here. So now, coming to step 3, we should check whether the number of times the basic operation is executed depends only on the size of the input, or if or it also depends on some additional property. We should investigate the worst case, the average case, and the best case efficiencies. So coming to the step 4, we have to check how many number of times the algorithm's basic operation is executed. Here the basic operation is not executed n number of times. This is because inside the while loop we have a condition where n is equal to n by 2, where the value of n is halved on each repetition of the loop. So the n value is takes on only few values between the lower and the upper limit. So we should use an alternate way to compute the number of times the loop is executed. So now, coming to the fifth step, you should establish its order of growth using the standard formulas. So now, as you've seen in the fourth step, the n's value is halved on each repetition of the loop. So now, how to find its order of growth? Since the n's value is half, the answer should be around log base 2n. The exact formula for the number of times the comparison operator is being performed is around log base 2n plus 1, which indicates when the while condition gets false. So now, as you see, the order of growth of this algorithm is O of log n. Thank you.